An alternative we can do is to use the information in here to figure out what the demand curve would be. So this information and the fact that it's important to remember that everyone wants to buy one car, so they all want to buy one car. They don't want to buy multiple cars. And so from this information alone, we can figure out what the demand curve is, right? So let's just try to draw out the demand curve really quickly. Okay, so the way to do this is to figure out, first off, what is the highest willingness to pay? Who is going to enter the market first, essentially? Well, from our graph, so from our table, we see that Ellen had the highest willingness to pay at $10,000. So before the price reaches $10,000, no one's going to want to enter the market, and so quantity will be zero. In other words, we can just sort of draw a vertical line at q equals 0 down to p equals 10,000. Then at 10,000, Ellen is going to jump into the market and buy a car, and she's going to be the only one to buy a car, right? At that price of 10,000, and so the quantity demanded at 10,000 will jump over to 1. And then we can think about, the next thing to think about is who is the second highest person? Who has the second highest willingness to pay? And it's Sarah here at 8,000. And so what we do is we take the line, we draw sort of a vertical line at q equals 1 between 10,000 and 8,000. And then at 8,000, Sarah's going to enter the market. She's going to buy one car. Ellen's still going to buy another car. And so the quantity demanded is 2. And so we just jump over the 2 here. Q equals 2 here. And you could just follow in the same basic procedure. Well, Winston is going to jump in at 4,000. And so we can draw this line all the way down to 4,000. And then he's going to enter, so we're going to have another car purchase, and we'll go up to 3. There'll be 3 buyers now. And then at 2,000, Sam will enter, and so this line can go all the way down to 2,000. And then it'll jump over to 4. And then after we reach the price levels 2,000, there's no more buyers enter the market. Everyone who wants to buy a car is in the market. And so we just draw a line down to the x-axis until we reach p equals 0. So from the willingness to pay, we can just figure out what the demand curve is by figuring out when people enter the market. Okay. So I'm going to actually make the demand curve a little bit bigger. Oops. Okay. So one of the things we were interested in was figuring out what the consumer surplus was when price equaled 9,000. And we saw before it ended up being equal to 1,000. The way to do it graphically is to start out by drawing a line at 9,000, sort of a horizontal line at p equals 9,000. And what we have is that the consumer surplus is the area under the demand curve above this price line at 9,000. In other words, it is the area of this sort of shaded area. And this actual area is the consumer surplus. And so to compute consumer surplus, all we have to do is compute the area of this sort of shaded region. And so let's just think about that really quickly. So let's say, price equals 9,000. Well, our consumer surplus here is a rectangle, right? This region's a rectangle, and we have to compute the area of that rectangle. And what it is that the consumer surplus equals our base times the height of the rectangle, so our $10,000 minus our $9,000, and then times the width of the rectangle, which is between 1 and 0. Well, that just ends up equaling $1,000. So here we didn't even have to think, now that we have the demand curve, we don't even have to think about, oh, who's entering the market, who's not entering the market, what is the individual's sort of willingness to pay, and what is the individual's consumer supplies. We can just basically take the area under this curve, and that will just give us consumer surplus. Let's look at sort of a similar thing, and let's change colors to orange. So actually, let's say now that our price is at 7,000. So what we need to do is here at 7,000, draw a line just like before. And I'm going to segment this into sort of two different areas. And I'll make sense in just a second. Not yellow. Let's go with purple. So the consumer surplus here is now just the area of this sort of shaded region, the multicolored shaded region. And all we have to do to figure out consumer surplus is to figure out sort of the area of this shaded region. And sort of with this step function, it's not obvious that this is easier than the equation approach. But in a second, when we do linear demand, when we do linear demand, we'll see that this actually is a lot easier than thinking about it using the equation approach with linear demand. Okay, so let's actually just compute out the consumer surplus really quickly. Well, the green area we know before, right? So we know the area of the green. Well, that just equals 1K, right? That's the same thing from what we computed before. Sort of the light blue area well, our rectangle goes from here 9,000 to 7,000. And then it goes from 1 to 0. I'm sorry, 0 to 1. And so this area ends up being $2,000. I probably should actually write the number here. It says this is 1. And then finally, our orange area, or sorry, our purple area, well, that ends up being a rectangle, getting ahead of myself with triangles. That goes from 8,000 to 7,000. And then from 1 to 2, and this equals $1,000 of surplus. Okay, and so in total, hopefully unsurprising, we get that our consumer surplus is equal to $4,000, which was the same as before, right? When the price was 7,000. So we just have to compute the area under the demand curve above the horizontal price line. If you've taken calculus, this is something related to the integral. It pretty much just is an integral. Okay, so now let's get back to the graph for a second. I shaded these regions colors for special regions. It's that you can actually sort of see the change in consumer surplus. So with the red line, we went from 9,000, sorry, the price changed from 9,000 to 7,000. We went from the red line down to the orange line. Well, before, sort of, we only received, when the price was 9,000, this is the only consumer surplus was this green area. Sort of that's all the old consumer surplus, or in other words, it's the consumer surplus of people who previously entered. Or sorry, let's just say old consumer surplus. I think this is actually easier to think about it. This is our old consumer surplus. And then from the price dropping from $9,000 to $7,000, we gained consumer surplus in two different ways. The first is this sort of light blue shaded region. And so this is the gain to previous entrants. So this is the gain to people who are sort of previous buyers. So what I mean by previous is, this is the gain in consumer surplus for people who are going to buy at 9,000 anyway, but saw that the price was 7,000. In this case, this is just Ellen's gain. And then over here, we have this purple shaded region, and this is the consumer surplus of new buyers. And that's their contribution to sort of consumer surplus. So it's important to remember when price changes, consumer surplus increases in two ways. One, previous buyers, people who are already going to buy at a higher price, gain some extra surplus. And then there's also new people who decide to buy at the new price and who wouldn't have bought at the previous price, and they get some consumer surplus. Okay, so let's go down and do one more case of consumer surplus where this graph approach ends up being really useful. So this case, yeah, we had these three different areas we had to compute, and it's sort of not that much easier than using the formula approach. But now let's consider the case of sort of linear demand.